Hello, Algebra 2 students. It is a Saturday morning. What better way to spend a gorgeous, gorgeous day than talking about graphing some parabolas? So let's get started. Here's our first equation, y equals x squared minus 2x minus 5, and we want to do a bunch of different things to this. We basically want to find out all of the important information and then sketch a graph. First thing we're going to take from this equation in standard form is we're going to pluck out this minus 5, which is the y-intercept. So I know I will have a y-intercept at the coordinates 0, comma, negative 5. Because that's what a y-intercept is. It's the y value when the x value is 0. So if I plugged in 0 for x in both of those spots, both of those first two terms would go to 0, and I'd be left with negative 5. All right, well, what next? Let's go ahead and find our vertex by completing the square. So to complete the square, I'm going to rewrite this. I know it's going to be a perfect square like that, x plus or minus something, and the pattern that we've noticed, the relationship, is that it will be half of that number, half of the b term. So half of that negative 2 is negative 1. And then I bring my negative 5 down. I still have that, but these two equations are not the same. I need to adjust, because if you expanded x minus 1 quantity squared, you would get x squared minus 2x plus 1. So I have changed the value of this by adding that 1 in that completed square, so I need to balance it by subtracting 1. Where is that 1 coming from? It's that number squared. So my final completed square will be y equals x minus 1 squared. Minus 5 minus 1 is minus 6. And now I can pluck the vertex straight out of there. I will have a vertex at the coordinates. That is going to be my h, the x value of my vertex, is going to be a positive 1, because if you plugged in positive 1 for x, that inside there would be 0. So positive 1, comma, negative 6, right there. That is my vertex. So I found my y-intercept, I found my vertex. Let's find our x-intercepts. And to do so, we're going to set this equation equal to 0, because if you think about how we found the y-intercept, we set x equal to 0. So to find the x-intercepts, we set y equal to 0. So 0 equals x minus 1 squared minus 6. And we're going to solve this for x. So we need to add 6 to both sides. So 6 equals x minus 1 squared. But I don't want x minus 1 squared. I want to get x, so I need to square root. So I need to take the square root of both sides. When I do so, on the right, the square and the square root cancel. On the left, I have plus or minus the square root of 6. Don't forget to take the plus or minus. That is what is giving us the two solutions for the x-intercepts. So let's simplify this. Plus or minus the square root of 6 equals x minus 1, but we don't want x minus 1, we want x, so add 1 to both sides, so x will equal 1 plus or minus the square root of 6. Now we cannot simplify the square root of 6 any further. The only factors of 6 are 2 and 3, which are both prime numbers, so we cannot split it up any farther than that. So those would be my two solutions in simplified radical form, but let's go ahead and get a decimal approximation for them. So if I take 1 and I add the square root of 6 to it, and this is fine to do on a calculator, I get roughly 3.449, so a little less than 3.5. So one of my x-intercepts will occur at 3.449, comma, the y value is 0. Let's do the other one. 1 minus the square root of 6 will give me negative 1.449. Notice that decimal bit is the same, so negative 1.449, again, comma, 0, because the y value is 0. The only thing I haven't found is the axis of symmetry, but that's the same as the x value of the vertex, right? So my axis will occur at x equals 1. Now that should be enough information to sketch a very good detailed graph, so let's go ahead and do that. So let's draw some axes. Think about the scale you're going to use and where your values are. Our y-intercept is negative 5, our vertex is negative 6, and we're kind of centered at the x value of positive 1. So if I draw some axes like that, I'm going to need some negative stuff and I'm going to be kind of favoring the right side of this graph. So let's go ahead and do some tick marks. If that's 1, I know I have my axis of symmetry running right there, and I can dash it in to show my symmetry line. And then my next important x values are 3.5 and -1.5 essentially. So let's go 1, 2, 3, 4, and then 1, 2, 3. There we go. That should be enough for us. Now let's do y values. 1, 2, 3, 4, 5, 6. And it's important to try and keep your scale as consistent as possible so that we can see the true shape of these graphs. So let's sketch this graph now. Where's our vertex? It was at 1, -6. So that's going to put us right there at 1, -6. Y-intercept right there at 0, -5. Because of the symmetry here, I know I'm going to have a symmetrical point right there at 2, -5, the same distance away from the axis of symmetry. So you should show it. And then my next points were at 3.5, basically. So 1, 2, 3.5. A little bit less than 3.5. So right about there. And then a little bit more than -1.5. So right about there. And we can label those. That was, well, you can label it with the exact values if you want to be super cool. We could call that, 1 plus the square root of 6, 0. But we know that was really, 3.449, 0. Either's fine there, 3 decimals or the exact value. And this one was 1 minus the square root of 6, 0, or -1.449, 0. So we have those points, and now we can sketch this graph in. That was poorly drawn, to the best of our abilities. There's 1/2. Ooh, I can do better than that. That was not very good, but we get the idea. It looks pretty symmetrical, and I feel like we found everything we'd want to find with this parabola.